Let us have a brief review of the procedure for drawing force and couple polygon as you were requesting last time. Let us repeat it again. And then we are going to start with unit number 6, that is free and forced vibrations, which we are going to start from today. So as we discussed earlier, looking to the data that is summarized in the table, which consists of magnitudes of centrifugal forces, centrifugal couple, angular positions of planes of various masses, then distances between various planes. And when that data is summarized in the table, you will see that there were some unknowns like angular position of plane 2 theta 2, angular position of plane 3 theta 3 is not known. Similarly, magnitude of mass 2 m2 is not known, magnitude of mass 3 m3 is not known. And while solving the problem, we have assumed plane 2 as the reference plane. We can see plane 2 here. When plane 2 is assumed as reference plane, so distances of planes towards its right will be positive, and of those towards left will be negative. And that is something which we have done in this particular table. If you have understood this table, I don't think there will be any problem in drawing force and couple polygon. So first we have to draw couple polygon. I don't think there is couple polygon in this case. Okay, but it will be there in front of you. For couple polygon and force polygon, both are there, right? No problem. So for drawing couple polygon, which we have to draw first, what you should do is first start from here. This is that point. Understand that magnitude is negative, so it should come towards left from origin. So this is the point, and it will come towards the left from origin. Let me give these points. Let's say this is O. Let us say this is O. Let's say, so that you will understand, this is B. And then this is C. So this is O, this is A, and this is B. O to A is minus 54. Angle is 0. You can now refer to the table. O to A vector is minus 54. So towards the left, angle is 0. Then after that, this is 0. So not required to plot it. Magnitude is 0. Direction is not known. But since magnitude is 0, there is no question of direction. This is unknown. So don't plot it right now. Whatever is known, go to that point. So it is 162. So let us plot 162. 162 is plotted. You will have suitable scale factor. 162 is plotted with angle 120 degrees. So you can see that minus 54 was 0 degree. 162 is 120 degree. This is 0, this is 90, and this is 120 degree. So 162 is the couple magnitude, angle is 120 degree. Now what is remaining is, this is plotted minus 54 at 0 degree. This is 0. So it is as good as plotted because it is a point. This was not known, so it was not plotted, it was kept pending. This is plotted 162 at 120 degree. So this is remaining. And you will see that now if you exclude the blue colored line, it shows that couple polygon is open, it is not closed, which indicates that system is unbalanced. So you have to close it. So I have drawn a blue colored line here. That vector BO is closing side of the couple polygon. So measure that closing side of the couple polygon. That will be equal to OB. Avinash, is there any question? Avinash, raise the hand. Okay, right. So you close this, and then this is closing side. This closing side is OB, but in the table it is equal to In the table it is equal to 0.225 m3. So equate 0.225 m3 to OB. You will get some value for OB. OB is the vector magnitude. So if you put OB value after measurement, after multiplying with scale factor, you compare it with 0.225 m3 on other side, you will get value of m3. You measure this angle made by this vector OB with horizontal from here to here. You will see here that angle will be 270 plus 270 plus, because this is 0, this is 90, this is 180, this is 270. So 270 plus something, or 360 minus something. That is how you will get magnitude of m3, and you will get magnitude of or value for theta 3, right? So two unknowns you will come to know. Once those two unknowns are known to you, multiply m3 multiply m3 here, you will get centrifugal force value. Why anti-clockwise? Which is anti-clockwise? This one you are talking about. So you can take in any way. If you measure it anti-clockwise, it will be 270 plus. If you will measure it clockwise, it will be 360 minus something. So it will be around 10-20 degree. So how you are noting down, that is important. If you measure it from here, it will be anti-clockwise. If you will measure it from here, it will be clockwise. Right? Okay. Right. So it depends on you. You should write down it as maybe 20 degree clockwise, or to 340 degree, sorry, 340 degree anti-clockwise. So the direction is important, and based on the direction, magnitude will change. Now, similarly, force polygon is to be drawn. Now, for drawing force polygon, you need magnitude of the forces which are there. This magnitude is known, direction is known. This magnitude is not known, direction is not known. So keep it as it is. This magnitude is now known because m3 is known to you. This theta is also known. So these two values are now known. What I would do is, this is known, this is also known. All that which is highlighted is known. This is known, this is known, this is known. Only this for second mass magnitude is not known, and its angular position is not known. So accordingly, you should use these two values while drawing force polygon. Magnitude of force from this column, direction of the force from this column. Use these two values which are there in front of you and plot it. So this is what I have done. Now once again, you should name it as, let's say this as O dash. Okay. Then this has A dash. Then this has B dash. That's it. This should be small. So 120 is magnitude of the force, angle is 0. Next, this is known now. You should multiply it value of m3. I don't have value of m3, therefore I have written it as it is. You will get this value, and you know this angle also, that is theta 3. m3 is known, theta 3 is known. So use m3 value and use theta 3 value. Use m3 value, find out centrifugal force magnitude. Use theta 3 value, plot this, and then you will see that this is plotted, this is plotted. Now next what you can do is, this also you can plot. This is 120 is the magnitude, 120 is the angle. This also I have plotted. So this is known, angle, magnitude, magnitude, angle, all are plotted. This colored line indicates that the side of the force polygon is open. Now since it is open, it is now closed, and that is equated to 0.3 m3. Equated to 0.3 m3. Measure this point. I think this point I should name. This point is C dash. That's how you should So you have to measure magnitude O dash C dash. O dash C dash, measure it, equate it to 0.3 M3, 0.3 M2. You will get value of M2, and then measure theta 2. Again, you have to measure it from horizontal. You will get it in anti-clockwise direction, or measure it in this direction. You will get it in clockwise direction. That is how you will get M3 and theta 3 after drawing force couple polygon, M2 and theta 2 after drawing force polygon. That is the way you should draw force and couple polygon. Actually, this was all explained when we had discussed balancing of several masses rotating in different planes. That methodology we are using here. So earlier it was discussed, but still let it be. I had discussed it again. Now let's start discussion on this topic. Single degree of freedom, free vibrations is a topic that we are going to discuss from today onwards. Single degree of freedom, free vibrations. Now, what are the learning outcomes? Learners, that is you, will be able to distinguish between single degree of freedom vibrations with and without damping. That is, you should know what is single degree of freedom vibrations with damping and single degree of freedom vibrations without damping. What is meant by damping? How vibrations are different, how their characteristics are different when they are having damping, when there is damping present, and when damping is not present. That you should understand. Derive an equation of motion to describe characteristics of free, damped, and undamped vibrations. So you also will be able to differentiate between free vibrations and free damped vibrations and free undamped vibrations, right? And then you should be able to derive an expression for equation of motion. Derive an equation to describe characteristics of free vibration. So we will see how equation of motion is written for any type of vibration. Then you will be able to discuss different methods of damping. Damping is very important in vibrations, which help you to reduce amplitude of vibration and which help you to reduce the severity of the vibrations. So what is that damping? What are different methods of damping? And how to characterize damping, that all you'll be able to understand here. Determine natural frequency and damping of free, damped, and undamped vibration. So you will be introduced with different terms like natural frequency, damping, time period, excitation frequency, and you will be able to know the expressions to determine all such parameters: natural frequency, damping, etc. Okay. These are the contents, as I said. You must have got some idea about contents of this particular unit. Unit is single degree of freedom vibrations, free vibrations. Single degree of freedom, free vibrations. So what is meant by degree of freedom? What is meant by vibrations? What is free vibrations? What is damped vibrations? What is undamped vibrations? What is natural frequency? What are different methods of damping? What is equation of motion of vibration? How to write that? How to read equation of motion? How to identify type of vibration from equation of motion? All that we are going to discuss. Lot many things. This slide gives you some introduction to different terms in the vibration unit, and all these terms we are going to be familiar in next coming few sessions. So what is vibrations? What are different causes and effects? What are the fundamental definitions? What are different types of vibrations? Classification of vibrations? What is equation of motion for vibration? Why it is necessary to write? What are the benefits of writing equation of motion? What are different methods of writing equation of motion? What is meant by equivalent stiffness of the spring when different springs are connected in series or parallel? Maybe more than one springs are used in the system. Springs sometimes are connected in series, sometimes are connected in parallel. When they are connected in series, how to find out stiffness of the spring for total system? When they are connected in parallel, how to find stiffness of the system? That we are going to study here. What are the characteristics of undamped free vibrations? Undamped means where damping is not there. What are the characteristics of damped free vibrations? And finally, what is meant by over damping, under damping, critical damping? And in that, we are going to see how to determine damping in the system using a method called as logarithmic decrement method. That this is something we are going to see, and based on that, we are going to solve examples. So in today's lecture, whatever we will be covering, let us be very clear with everything, because whatever we will be discussing, that all is fundamental. These are all fundamental concepts, and you are supposed to make use of these concepts time and again, and you should be very familiar with, or the understanding of these concepts should be very sound so as to proceed further. If all these fundamental concepts, different types of vibrations, different fundamental definitions, if all this is understood very well, equation of motion, if all this is understood very well, then you will be at ease in understanding the further subtopics of this particular unit. So what is vibration? How will you define vibration? Any motion which repeats itself after equal interval of time is called vibration. I have tried to put number of figures in front of you so that you can easily understand. Any motion which repeats itself after an interval of time. So this is periodic motion which repeats itself. This is repeating after interval of time. So it has started from here, half cycle is completed, full cycle is completed. Okay. So any motion which repeats itself after an interval of time is called vibration. Now, in any vibratory system, some examples of that are machines with repetitive power sources such as engine, motor, turbine. Even not that, you can just observe when you are passing by the uh, sound that the telephone wires are created. Telephone wires are creating. Telephone wires are also vibrating when wind will be flowing over those telephone wires. When wind will be flowing over the buildings, buildings also will vibrate. So if that intensity of the wind flow is very, very, very high, buildings have also collapsed in the past. So due to the force of excitation, so here wind which is flowing over the telephone wires is providing the excitation force, and due to that excitation force, telephone wires are vibrating. Due to some excitation force, chassis frame of an automobile is vibrating. Due to road irregularities, road excitations from engine, unbalanced forces from engine. We have just discussed what is meant by unbalance, what are different types of balancing, how to balance the system, that all we had discussed earlier. So what is the effect of vibration, balancing? One of the prominent effects, unwanted, undesired effects of unbalance rather, is vibration. Unbalance creates vibrations, and due to that unbalance, system will be subjected to vibration. Unbalance is not the only cause for vibrations. Vibrations might be caused due to number of other reasons. So, but yes, unbalance is one of the reasons. Due to that, system will be subjected to vibrations. This you must have experienced when we had conducted an experiment on balancing of several masses rotating in different planes. When the masses were not balanced, system was vibrating. When they were balanced, system vibrations were reduced. Right? So this is vibrations. Now this figure shows you three important elements in any vibrating system. Listen carefully each and every term right now and raise all the questions wherever you feel that we should repeat it again, if it is not understood, of course. This figure shows you three basic elements of any vibratory system. Any vibratory system consists of three basic elements. So this is spring, this is damper, and this is mass. Spring, mass, damper. These are the three basic elements of any vibratory system. Okay, spring has stiffness equal to K in Newton per meter or Newton per millimeter. Damper has damping coefficient C, and mass is having magnitude kg. Damping coefficient in Newton second per meter, which we are going to discuss afterwards. So spring with stiffness, damper with damping coefficient, mass which is system mass. System which is vibrating, mass of that system is mass m here. And if the vibrations are forced vibrations, you can see that this system is subjected to some excitation force. Ft is the excitation force, its magnitude is F cos omega t, and due to that now system is subjected to vibration. Due to that vibration, due to those vibrations, amplitude of vibration is X. You can now imagine that if force of excitation will be acting in downward direction, system will deflect in downward direction by amplitude X. Now, the system may have two elements or three elements. If damping is not there in the system, damper is absent. But if system has damping, then in that case, damper also will be there. Okay. So if damper is present in the system, it is called as damped vibrations. If damper is not present, it is called as undamped vibrations. This one more figure shows you amplitude versus frequency plot. With frequency, how amplitude changes, that is shown here. And you must have heard one term n number of times earlier, that is called as resonance. So what is resonance? I have tried to demonstrate here. What is resonance? The frequency, at certain frequency, amplitude becomes very high. You can see amplitude is not high here, amplitude is not high here, amplitude is not high here, it is also not high here, amplitude is less, but this point amplitude is very high. So the frequency at which amplitude is very high, it suddenly increases, is called as resonant frequency. And this frequency at this point, natural frequency of the system and excitation frequency of the system are equal. So what is meant by natural frequency? Natural frequency is of the body. For example, chassis. Chassis has certain natural frequency due to its properties, natural properties, material properties, geometry, etc. And something will be vibrating or making the chassis to vibrate. So that something which is making chassis to vibrate, that also has certain frequency. Let's say road excitations. So road excitations will be coming to chassis and that will be making the chassis to vibrate. So frequency of road excitations is called as excitation frequency or post frequency. And frequency of system which is vibrating, that is called as natural frequency. जी सिस्टम व्हायब्रेट होते त्याची फ्रिक्वेन्सी म्हणजे नॅचरल फ्रिक्वेन्सी. ती तिच्या प्रॉपर्टी, जॉमेट्रिकल शेप याच्यावर डिपेंड असते. आणि ह्या सिस्टमला जो कोणी व्हायब्रेट करतो असा काही फोर्स असतो, त्या फोर्सची फ्रिक्वेन्सी म्हणजे एक्सायटेशन फ्रिक्वेन्सी असते. राईट. मग सिस्टमला व्हायब्रेट करणार कोण कोण असू शकतं? वेगवेगळे एक्सायटेशन सोर्सेस असू शकतात. देर आर सो मेनी एक्सायटेशन सोर्सेस. दोज कॅन व्हायब्रेट दी सिस्टम. लाईक आय सेड, टेलिफोन वायर. Who is exciting their wind flow? So there it has certain excitation frequency. And telephone wires as a system will have natural frequency. It depends on shape of telephone wire, its material, etc., etc. So when natural frequency of vibrating system and excitation frequency of external agency, when they are equal, that is resonance. And when resonance occurs, amplitude of vibration is very high and amplitude of vibration becomes detrimental or of magnitude which is not tolerable, because that amplitude of vibration of the system is likely to cause failures of the system. What are different examples of vibrations? Machines with repetitive sources, engine, motor, turbine. I have also told you a number of examples while we were discussing. Motion of pendulum, machine tool vibrations, tuning fork, vibrations of strings of musical instruments. Vibrations of strings of musical instruments is something where vibrations are desired because their vibrations are causing the musical instruments to work. But in machines, vibrations are not undesired. So in some applications, vibrations are desired, but there are many applications where vibrations are undesired, right? Elements of vibrating system, I told you three basic elements: spring, damper, mass. It depends on what type of vibrations it is. If it is damped, then spring, damper, mass. If it is undamped, then spring and mass only. X is amplitude of vibration, F is force of excitation. These are some fundamental terms based on the earlier figures that I have shown you. You can see periodic motion is motion which repeats itself after equal interval of time is called as periodic motion. I told you earlier. Cycle, movement of vibrating body from its equilibrium position and then back to equilibrium. Cycle. So this is cycle. So cycle is started from here. Half cycle is completed here. Again it come back to its equilibrium position. It starts from here. Half cycle is completed here. It come back to its equilibrium position. Now here again next cycle is started from here, ends here. So this is called as one cycle. So what is cycle? Movement of a vibrating body from equilibrium position and then back to equilibrium. Time period. Now see time period. Time taken to complete one cycle. If cycle is understood, then see T0 is time for this cycle. T1 is time for this cycle. So what is the time? From this point to this point. Time taken. What is time period? If this is cycle from this point to this point, then time taken to complete one cycle. See, cycle is starting from this point. Half cycle, one cycle. So distance between these 2 points, 1 and 2. Distance between this point and this point and this point. That is called as Nihar. Don't be in hurry. Roll number 51 also. Don't be in hurry to enter your attendance. We are going to do that after the break. There are last 2 minutes of first session. We are going to continue for another 20 minutes and then you can enter your attendance. I think I'm telling it every time. I should not repeat it. Same thing again and again. Right? So don't be worried about your attendance. I have given you a chance to update your attendance again. Today again you can update your attendance in the Google Sheet that is provided after this lecture immediately, because I know that your numbers are here also and there are 49 students present at this point of time, right? I can see the numbers. You can accordingly update your numbers in the Google Sheet also, and then that is how your attendance will go on building. But I told you that I believe in you. Don't enter your attendance if you are not present. You are not going to get nothing from that. Okay. So these are three basic elements of vibrations: periodic motion, cycle, time period, amplitude. Now what is amplitude of vibration? Maximum displacement of vibrating body from its equilibrium position. I have made a number of things very clear here. This is amplitude of vibration from equilibrium point to maximum displacement. So this is the amplitude of vibration, amplitude versus frequency, right? Amplitude versus frequency. This is amplitude of vibration. Then next, natural frequency. When natural frequency depend on properties of the body or material of the body. when no external force act on the system after giving it an initial displacement, body vibrates rather. Frequency of these vibrations is called natural frequency, right? So what I will do now is, after the break, when we are going to start our session for another 15-20 minutes, so I will count the number and that number will be considered for attendance today. Right now there are 50 students present at this point of time. In the next session, whoever students will be present, their numbers will be considered for attendance, and those I will ask you to update in the sheet, right? Aman, Prajwal, Shubham, Sanket, you need to enter your numbers again after the break. Maximum displacement of vibrating body from its equilibrium position. Natural frequency, when no external force act on the system after giving an initial displacement, this is called as natural frequency, that is frequency of the system. Frequency of system without any external excitation. Frequency of the system without any external excitations is called as natural frequency. That is, when no external force is acting on the system, then at that time whatever frequency system is having, because of its own properties, material, shape, that is called as natural frequency, or it is also called as frequency of free vibrations or natural vibrations. Natural vibrations are those vibrations which are not function of excitation frequency. For example, again let me give you the example of chassis. So chassis will have its frequency without any external excitation. That frequency is called as natural frequency. And when that chassis will be subjected to some external excitations due to road irregularities, due to engine vibrations, etc., etc., that frequency of those excitations, external excitations, is called as forced frequency or excitation frequency. And natural frequency is frequency of the system when no external excitations are acting on the system. Okay, right? So fundamental mode of vibration. Fundamental mode of vibration of the system is the mode having lowest natural frequency. Fundamental mode of vibration is mode having lowest natural frequency. So the system may have n number of natural frequencies. First natural frequency, second natural frequency, third natural frequency, depending upon degrees of freedom, right? So Sanket, but then how we can cover our syllabus? That is the point. I can understand. And whenever you had requested, we are taking or we are stopping also. Today also we will stop. That's not an issue. Only thing that I want to know from you is how then we can cover our syllabus. Let us decide that, because we have to cover one full unit. Let me know how to do that, and then accordingly we can decide. We can take a decision how we are going to cover our syllabus.
Sir, but from morning we had nothing, so we need the lunch break, sir.
लंच ब्रेक आपण आपल्या 1:05 ला आपण घेतला तर चालणार नाही? मला वाटतं ते किती वाजले?
सर 1:30 वाजलाय. ऑलरेडी टू लेट.
ओके ओके 2:05 नाही, पण का बरं तुमचा 12 वाजता नव्हता का लंच ब्रेक? हॅलो,
हा रेग्युलर 1 वाजता जेवायची सवय आहे, पण 1 वाजता लेक्चर होतं सर तुमचं.
अरे पण 12 वाजता तुमचं मध्ये ब्रेक असतो तेव्हा लेंथ करून घ्यायचं ना, कारण ही आपली लेक्चर आता कॉलेजच्या टाइम प्रमाणे असणार 12:55 ते 1:55 असणार.
सर त्या इलेक्टिव्हचं लेक्चर होतं जीवन विद्याचं.
सगळ्यांचं होतं?
नाही सर, आपल्या क्लास मोस्टली होतं सर.
क्लासेस प्रमाणे आपल्या सब्जेक्ट प्रमाणे, इलेक्टिव्ह सब्जेक्ट प्रमाणे.
आपण फक्त तुम्ही एक काम करत जाता, लंच ब्रेक तुमचा 12 ते 1 असतो, त्यामध्ये लंच करून घ्यायचं तुम्ही. हे 12:55 नंतर वॉट एव्हर लेक्चर वी हॅव there we cannot break for lunch. Yeah? I can understand if there was lecture in the morning and therefore you did not get time. Last time we did that. But today if there is time and we are running our lectures during regular time. So at that time, I think we should not disturb ourselves from attending the lectures. Okay. So what we'll do is we will complete this session in next 2 minutes, and then today we will stop. But then next time onwards, let us see that we will have two sessions. First meeting and second meeting. Is that okay? Hello? Everyone? Is that fine? Let me know. We are not able to complete 40 minutes even. So how we can go ahead? आणि कुणाचं लेक्चर असतं मला जर सांगा बरं 12 वाजता. आय कॅन टॉक टू देम. आज कुणाचं होतं लेक्चर? संकेत? हॅलो? Let me know who has conducted lecture at 12 today, because it was in odd time. Sanket, now speak so that we can stop. Let me know from you now.
सर सर्वांचं नव्हतं लेक्चर, थोडं इलेक्टिव्हचं होतं आज.
होय की रे,
सगळ्यांचं
माझं-
मिक्स नव्हतं.
कोणाचं आहे सांगा ना मला, त्या सरांचं नाव सांगा सो दॅट आय कॅन टॉक टू देम.
नाही आमचं तर नव्हतं आज. कोणाचं होतं इलेक्टिव्ह ते माहित नाही मला.
So then still you are requesting that you should break for lunch. Why you are saying that?
पण सकाळपासून आम्ही काही खाल्लेलंच नाही, त्यामुळे मी म्हणलं की लंच ब्रेक हवा आहे.
I thought that there was a lecture. So I thought that there was lecture at 12. असं होणार नाही आपल्या टाइम टेबल प्रमाणे.
होतं सर, जीवन विद्यार्थी दुसऱ्या विद्यार्थ्यांचं होतं आज लेक्चर 12 वाजता.
ठीक आहे ठीक आहे. ज्यांचं आहे त्यांना आपल्याला रिक्वेस्ट करता येईल की त्या वेळेत नको लेक्चर घ्यायला. आय कॅन रिक्वेस्ट देम सो दॅट इट विल नॉट डिस्टर्ब. ओके. So we will stop today, and then from tomorrow onwards we will have full lecture, so that we'll be able to cover only one unit is remaining. Everything is going fine now. There is good response from your side also. We should continue with that.